Hi guys, welcome to tutorial number 2, and today we're going to continue our look at coding in processing. So today we've got some more difficult questions for you to complete, but we'll start working our way through. So we start sort of quite softly. We're going to look at constructing some declaration statements for the following array. So we've got to declare an array to store 30 integers, 100 floating point numbers, and 15 strings. So if we jump up to our coding window here, we don't have to initialize these with any particular values, so we can just start by creating, if we want to create an integer array, we can create an int array, and we can call it my int array, so just like we do any other variable. And then when it comes to using this one, we then have to specify, we have to create, so we've created a placeholder or a variable to store our array. Now we actually have to go and create our array, and so we created a new int array, and we want that to have 30 integers in there, so we put 30 in the scripting there. So essentially we've created an empty array of 30 integers. So we declare the integer array variable, and then we create a new array and assign it to the myIntArray variable. So that's pretty straightforward. That's the pattern that we follow for all of these questions. So if we want to create our floating point array, we create my float array, and then we jump down and we have my float array. Oops, I've missed that one. Equals new float array, and we want to have 100 of those, and the final item there is our 15 strings. So remember that a string is an object, not a primitive type, so it has a capital S. We can still create an array of these objects, and again we just go and we have my new string, and we want to have 15 strings. So we've created our array of 15 strings. So that covers off, that's a pretty straightforward little exercise. So remember, we have to declare our array, then we have to actually create and assign the memory for the array. So it's a two-step process. We can now go and use that in a for loop, or we'll see later on that we can do all sorts of bits and pieces with that array. So our second question asks us to see if the following declarations are valid or invalid, and we can test these by dropping them into processing. So the easiest way is just to, we'll clear out our previous code, but we just take our question here, and if we drop it in, so recall that in processing, if there's a syntax error, we get the little red squiggly line appearing under anything, and you can see straight away that we've got a red squiggly line under this because we have a duplicate local variable name. So we've declared the variable, the array numbers twice. So the answer to part A is no, it's not a valid declaration. So if we move on to part B, let's have a look and see what's going on here. So if we drop this into processing, you can see that we actually still get an error here. Let's see what's going on. So we've got an integer called num, and we're trying to assign, we're using that num to create a new integer array. But the problem is we're trying to assign that integer array to a floating point array variable. So it's not going to allow us to do that because integers are different from floats. So again, part B is not legal. Let's go and have a look at part C here. Part C is the same as part B because I think there's a typo there, but let's have a look and see just to make sure. It should be the same question. Yeah, I've got the same problem again. If we move on to part D, it looks a little bit more complicated. You can see here that we've actually spread our commands out over multiple lines, and we still have a little squiggly line under here, but it's not the red squiggly line, it's just saying that the value hasn't been used. So we've got an integer, and we're assigning the value of an expression to that integer called num. We're then creating a new floating point array of num equals 5, so the value of that expression is going to be 5. So we're creating a new floating point array, and when we execute that code, there shouldn't be any errors returned. So it doesn't actually do anything, but it doesn't return any errors. So D is a valid declaration. If we have a look at part E, let's go and drop that in to our processing editor and see what's going on. So again, we've got our number, we've got a string array variable, and we're assigning a new string array to it, and the size of that is num times 10. So that's a perfectly legal declaration because we're just getting the number of elements by multiplying num, which is declared before, and set to the value of 5 by 10. So we've got another legal declaration there at the end. So fairly straightforward. So points to remember there are that you can spread your declaration across multiple lines. So white space in the Java language that sits underneath processing doesn't really mean anything, and you can allocate the space, the number of elements in an array, based upon the value of a variable. So it's an interesting concept because it means that our arrays can have a different length every time we run our program if we change the value of the variable that we use to allocate the space in them. So quite an interesting concept. So we'll move on to part 3. So part 3 is construct a set of for loops. Set each value in an element in an integer array to its position in the array. So this one, I'm going to use a for loop. So we only actually need one for loop. We don't need loops. So remember that the syntax for a for loop is for, and then we have an initialization for a counter. So I'm going to call it counter equals 0. Then we're going to count. Actually, before we go any further, I'll need to set my array up. So I've got my integer array, and it's going to have how many elements in there. So I'm actually going to use this one here. Actually, no, we don't even need to have values in it. So let's go int array, my array equals new int 10. So let's go through and do that. So let's go count. So we have to put a terminating conditions. This is the condition that will make our loop finish. That's when we get to the end of my array. So that's going to be less than my array.length. So remember that arrays are actually numbered from 0 up to the length minus 1. So if we start at 0, we just need to count up, and then as soon as we get to the, and soon as our counter is equal to the length of our array, we need to exit. So whatever count is less than my array, we want to iterate through, and we need to increment count. So I'll just make my window a little bit wider here. Count plus plus, or count equals count plus 1. I need to make my window just a touch wider. Close that off, open up a bracket, and now we're ready to do some coding. So the idea here is that we want to set the value of each element in our integer array to be its position. So in other words, we want to set the value of my array, oops, I'm missing an equals there, the value of my array at position count, because count is keeping a count of the position that we're up to be equal to its position, which is saved in count. Now we can go through and print that out. So we'll go print ln. We'll print out the value that's stored in that variable just so that you can see what's going on. So we've got no red squiggly lines. Let's go and run our code. You'll see that when we run our code, we get a window displayed even though we're not doing anything in it, but we get the numbers 1 through 9 displayed at the bottom. So that means that each item's position is being saved in the array. So it's really straightforward in code, but it's a bit tricky to get your head around if you haven't used loops much before. So let's go and change that over to a while loop. So we'll create, this is the alternate approach, we'll create an int called int count equals 0, while count is less than our array length, so we drop that in there. Length, so the length attribute is available to get the length. Now the only thing we have to remember here is that we need to increment our items. So, whoops, I've capitalized that as well. So we need to have, so at the moment our loop will never end, so we have to increment our count variable. And when we run that, we should get the same result that we got before. Again, you can see in the console down here, we have the numbers 0 through 9 drawn up. So 2 different approaches to answer question number 3. So now we're moving on to question number 4. So question number 4, given this pre-allocated array, so we're specifying an array of 10 integers here, we have to write some code to do some operation on that. So I'm going to get rid of all of this stuff. I'm going to drop my 10 integers up the top. Now the first question asks us to square each number. So we want to multiply each number in that array by itself. So again, I'm going to use a for loop to do this. Create a counter. So let's call it count. And we've got nums up here, so I'll grab that one. And then we need to increment our counter. Oops. And I'm going to use the shorthand this time, so count plus plus. So this is shorthand for count equals count plus 1. So if I drop that in there, now the operation that we have to carry out is multiply each number by itself. So we will need to set the value of nums at location count to be nums at location count times nums at location count. We can print that one out while we're at it, just so we can see what's going on in our program. Drop that in here. No red squiggly lines, and when we print that one out, when it runs, you can see we've got 25, 16, 4, etc., which is the square of each of those numbers. So we're multiplying each number by itself in the array. So that's the answer to part A. If we go down to part B, we're adding a random number between 0 and 10 to each number. So this one's really easy. All we need to do is modify our code here, and we're going to use the random function. And we need to add a number between 0 and 10. Now there is one little tricky thing that might step us up here. Now we've got a red line underneath this, and if you go over this red line, you can see it says float doesn't match int. Now the problem here is that we've used this random function call. Now the random function call returns a floating point value. So if we go down to the documentation here and have a look at the random function, you can see that the return type is a float. So we need to convert that over to an integer. So if we go and have a look in our items here, we should be able to find some conversion functions, or we might even be able to find a round function. So let's have a look. Array functions control, trigonometry conversion. Should be able to find some conversion functions. So here we have a function called int, so it will convert anything over to an integer. So all we need to do is wrap all of this in an int call. So if we do that, you can see that. So the result of this expression will now be passed to the int function for conversion into an integer. And when we run this, see that we've got some random numbers here. So you can see they're going to be random because they're going to change because the random number returned is going to be different every time we run our program. So that gives us an answer to part B. Now we need to move on to part C. So add each number to the array, add to each number the number that follows in the array, and we need to skip the last value. So all we need to do is, again, we want to skip the last value. So I'm going to straight away just go up and put a -1 in our condition here. So we want to stop at length -1 because we're going to skip the last number. And then we just need to go back down here, and we're going to add, we're going to make it the sum of at each number to the number that follows. So we're going to add nums to nums count, and we want to get the next position. So we want to increment we want to get our counter plus 1. So note that this doesn't increment the counter because we're not assigning the value of this expression back to count. All we're doing is getting the value in position nums count plus 1. So if we go through and play that one, you can see that we get 9, 6, 9, etc. So when we add, so 5 plus 4 is 9, 4 plus 2 is 6, 2 plus 7 is 9. So we're getting exactly that, and we should have only 9 things displayed there because we're missing one from the end. So that's our answer to part C. Next one, we need to calculate the sum of all of the numbers. So to do that, I'm going to create an integer called total, and this is going to store our total of all of our numbers. And all we need to do is go total. I'll move that one. I'll get rid of that for a second. And we don't need this one here either. We'll go total equals total, and we want to add each of the numbers at position count to the total. And at the end we might print out the total as well. So if we drop that in here, oops, drop that in there. So now we can go right through. If we go and run that, we should just get one number printed out at the end and 61. So if we add those up, that'll be the total of all of the numbers, the sum of all of the numbers in there. So the next exercise, the final exercise, asks us to get the average. So what we mean by the average is the mean of all of our numbers. So all we actually need to do, if we want to do it a really easy way, is we just divide our value by 10. So that will give us our average, because we have 10 numbers in here. So if we do that, that will work quite well. The average is 6. Another option is to divide it by count minus 1. We have minus 1 there because when we finish this loop, actually we won't be able to access count in there. I'll need to move count up to there, drop that off there. So now if we change the value of, we change the number of elements in our array, it will dynamically update that. So if we go, we've calculated, we've got the same result, but if we add another item here, so if we add 20 to our code here, we should get a different average. So it's an average of 8 instead of 6. So that's just a nice way of calculating, counting the total number of items in an array. So it's going to be count minus 1. So we had to move the integer, the int declaration outside the for loop, because when we declare something as part of the head of a for loop, it's only available in the body here to use. So down here we had a red squiggly line because count wasn't available. So we moved it up in front of the for loop. So now we can access it outside of the body of our for loop. So there's a nice quick answer for that one. So I'll clear all of that off because I suspect that we're moving on to some different questions now. Now we're moving on to question 5. So question 5 has we're asked to write a loop that will actually go through and draw all of these lines. So straight away we're going to count how many lines we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 lines to draw. So I'm going to quickly create a for loop. So a really quick for loop to do some drawing. Then, first of all, we might grab these items here that set up our canvas. We can drop them out the front here. So now we need to go through, and you can see that each time the function runs, we're actually incrementing these values by 10. So I'm actually going to change this to I equals I plus 10 so that our counter increments by 10 each time. That way we should just be able to, I'll even start our counter at 50, because we're going up to 150 in both situations. So if we start our counter at 50, and we'll finish up at 150. So then all we need to do is just go line, we'll use the line function, we're going to use I, then we're going to use 60 because 60 is fixed, 60 is fixed the whole way down. Then we're going to use I again, and then we're going to use 80 because 80 is fixed all the way down through our lines. Terminate that one, and that should draw the lines that we want. You can see that we've got our lines drawn across the screen. So just a nifty little way of completing that using a for loop. So there's some nice quick and dirty code that shows you how to implement a loop. Now, the next couple of questions you've been given, for question 6, you've been given some images, and you've got to recreate the code, recreate what's in there. So the first one, we've drawn some lines down the page there. So I'm not going to bother counting how many of them are, but I'm just going to place a line every 10 pixels. So I'm going to use the loop that we've got here, and I'm actually going to use the height variable in here as the terminating condition. Oops, it should be EIGHT, and I'm going to increment it by 10. Then I'm going to draw a line from 0, I, so I'm going to use I as the y coordinate, and then I'm going to draw that one to width I. So let's see what that gives. That should get us close, if I'm not mistaken. Let's see what we've drawn. So you can see that we've created the same pattern there. So essentially, we have a counting variable I. So while ever I is less than height, we increment it by 10, and we draw a line from 0, so right over on the left-hand side, over to the right-hand side at the Y position of I. So that gives us that same picture. So the next one, we have to draw some ellipses. So first of all, I'm going to go and have a look at the ellipse function, because I can't remember exactly what we're doing with the ellipse. So ellipse, we specify a center point, and we specify a width and a height. So that should be fairly straightforward. So if we go through and we go ellipse, oops, there's a double L in there, and we want that to appear in the middle. So I'm going to use the width variable and divide it by 2. And the height variable divided by 2, and that should put it in the middle. And then I'm going to use my I variable, which changes each time, to actually to essentially specify the size of my item. Now the size of my the width and height of my ellipse, so it's going to be I and I. Now the problem is I'm going to make some really big ellipses here because they're going to get too big too fast. So I'm going to set that, maybe, how many ellipses do we have to actually draw? So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I might specify, I might go while ellipse is less. So we might go the other way. I might go ellipse greater than 0. We start at 100. And then we subtract 10 every time. So let's go and have a look and see what that draws. Well, we kind of got close. So the only thing that's left is we need to specify the, I might change it, I might start at it. We might scale up our solution here. We might start it at 200 and we might subtract 20. So what does that give us? So you can see I've scaled up our solution. So you can see that the color changes with each one as well. So I'm going to I'm going to use the fill function, and I'm just going to use fill I. That should get us somewhere near that one, and you can see that's exactly what we've created there. So we're using the I value, which is going to range from 200 down to 0, to specify the color value. So we're only using a single value in the fill function to give that to specify the grey value. So it gives us a nice quick and dirty solution for that problem. So now we're moving to our next item, which is this lovely pixelated looking thing of random white noise pixels. So straight away we're going to be placing pixels in the X and Y direction. So I'm going to create a couple of nested loops. So I'm going to have my X variable in the outer loop, while ever x is less than, I'm going to use width here, while ever x is less than width, then we're going to have to increment that. So I'm going to increment x by 10 each time. I'll do that very explicitly. Then you've got 4, oops, and I'm going to put my y variable on the inside. Y is less than height. Got my height variable. Y equals y plus 10. Space that out so it looks nice and pretty. Drop that in so I can terminate that one. Match up. So remember, you've got to match up all of your closing items. So here, in order to build this, I'm going to draw a little tiny square in here. So I'm going to use the, let's go and see what functions we might use. I think I might use the rect functions, the rect function. So, so we're going to use the top left-hand corner. So we're going to have a rect. Top left-hand corner is going to be x and y. Then the size is going to be 10, 10. Now I want to randomize the color in my item, so I'm going to just randomize that using the fill function again. So fill random, and I'm going to make that between, so I want a random number between 0 and 255. So I'm going to be happy to accept that. Let's go and see what that draws. So that's pretty much it. So the only thing that I've got to fix up here is I've got little outlines around my pixels. So if we go back to the drawing, there was no outlines around the little pixels. So I need to go and get rid of that. So I just need to go and put no stroke on. Oops. I'll learn how to spell eventually. And once I run that, that should give us what we want. Oh, no, I'm getting a stroke. Why am I getting stroke? It's because I've got stroke below it, sorry. There we go. So every time you run that, you should get a different configuration of light and dark squares. Now, if we wanted to go and adjust that so we get a nice bright set of colors, we can randomize all 3 color channels as well. So if we go through, we can randomize all of them and create nice pretty patterns there. And again, you can muck around with the color scheme here, so you can randomize that to 50 and get nice blues, and mess around with the color palette as well. So quite a bit of fun. So that covers off on the code to create all 3 of those items. So let's not save that one. Oops, I need that again, sorry. Grab a new SketchUp. Sorry about that. So let's go to the next exercise. So the next exercise asks us to break down a function, break down a program into some functions. So I'm going to start by grabbing the big blob of code, and we need to create 3 functions. We need to create move, bounce, and display. So first of all, I'm going to start by creating the move function. So it's going to not return anything. I'm going to call my function move. I'm not going to pass anything in. I'm just going to keep things really simple. So that's my move function. Next, I'm going to create my bounce function. So again, bounce won't take any input parameters, nor will it return anything. So bounce needs to check if it's going to hit the side of the window, and the final one is display. Oops, I need to put a return type on there. So I put a return type on display, then we drop in the code for our display. So now we have our 3 functions, move, bounce, display, so I should be able to replace all of this code up here with the new one, and if we go and run that, it should run our program for us. So we've got our bouncing occurring. So it's similar to the program we looked at in tutorial 1. So all we've done here is move all of these operations into their own individual functions. We've given those functions a name and we've put a return type on each one. So really simple, but just to show you how to break down your code into different bits and pieces. So the final option here, the final piece of code here asks you to break down some code. Actually, it's not the final one. It's the next exercise asks you to break down this lump of code into some reusable functions. So this is the code. If we go through and run this one, you'll recognize that it actually draws Pac-Man. So you can see that we've got Pac-Man going here. So we're going to break that down into some functions by first of all creating an update function. Then we can create a draw function. Oops. Which we'll call draw. So draw is a reserved word, so we'll call it draw Pac-Man. So straight up, we'll just go and grab all of the bits and pieces that we need to draw Pac-Man, and we can drop that into here. And replace that with a call to our function. Then we can drop that into the update function and call update. So we can replace all of that code with update, which is all we need to do. So now we should be able to run that, and that should be exactly the same as before, but we've created some functions. Now, the problem is that we haven't really made reusable functions. So what if we want to change the position of Pac-Man? So what we're going to do here is actually create something that's a little bit more usable. So I'm going to create one called draw Pac-Man. I'm going to include an int x and an int y, and I'm going to use these as my position variables for the ellipse. And so this one needs to be x and it needs to be y minus 25. Now I'm going to pass just the center of, let's just check, I bet you I didn't get that I quite right. No, I did get the I correct. So now we've made something that's slightly more usable. We've actually made it so that we can draw our Pac-Mans. And in actual fact, if we go and make our canvas a little bit bigger, we can draw multiple Pac-Mans. So if we make it 400 wide by 200 high, so let me check I've got that correct, we should be able to draw another Pac-Man in there. So if we go and have a look, grab our Pac-Man, we should be able to draw one at 300, at position 300. Oops. They should work in, oh, no, we didn't quite get that one right. What's happened there? The colouring isn't quite right on them because we haven't set something back. It's because our stroke colour hasn't been set correctly to draw our, what have we done here? So we've drawn Pac-Man. So we've got to debug our program. So what's happening? Let's go and see what's going on here. We've drawn our eye with an outline, but we're not drawing our big arc. So why aren't we drawing our big arc? That's because we've made a mistake. If we go and have a look, there we go. We've corrected our mistake. We had the x value in there twice. can see that now we've got more Pac-Man. Now, the only thing that we could do to improve this more is that we could make our update a little bit more user-friendly, but I think by putting the start and stops in as parameters, but I think that's probably enough to qualify as a reusable function. So we'll leave that one and move on to the next question. So in exercise number 10, we are breaking down, we're creating a function called drawCar. Now, I'm actually going to leave this question because we did a very similar example when we looked at our drag racing example in lectures. So go and have a look in the lectures for that one. So the final one is to create some functions. So we've got 4 functions to create here. So the first one is to create a function called distance that takes 2 points and calculates the Euclidean distance between them. So that's a pretty straightforward one. We'll return a floating point number for this one. Did I ask? Yep, so it returns them as a floating point. So float distance, and it takes 2 sets of x, y coordinates. So we go int x1, int x2, actually make that y1, sorry, int x2, int y2, and we're just going to return, what's going on here? Yep, so that's all exciting. So we're going to return, so we have to do some mathematics here. We're going to have to go and remember our maths functions. So if we go back to the reference here, you can see we've got some maths, we've got some operators, we've got some calculations. What we're really interested in is the square root, actually. So return sqrt of x1 of x1, x1 minus x2, and there should be a square function. Does that do what I think it does? Squares the number, so we should be able to sq. So we square that plus the sq. We should have y1 minus y2. So what's the direction we're going? And that should give us what we want to do. So we want to grab the square root of the square of that plus the square of that. So that should get us sorted, and that will return our distance. That's the first function complete. Let's go and have a look at the next one. The next one is return one called rectangle. It accepts the height and width of a rectangle and returns the results. This one's a really easy one. Float should be the width and height, so we'll go int w, int h, and all we need to do is return w multiplied by h. Done. So C, we've got to do one called mouse position that draws a string of text on the top corner of the window that contains the current x and y position of the mouse. So what are we calling it? We're calling it mouse pos. So this one doesn't return anything, so let's go void. Doesn't even need to take anything in, so we need to go and have a look at our text function. So the text function, which lives here somewhere, should have an x and a y position if I'm not mistaken. It's the first, no, it's the second variables. Okay, so all we need to do is text, and we need the text that we want to position, which is going to be, we'll make it mouse x We're going to create a string out of it, so mouse Y, and we'll display that up at, say, so it's the top left-hand corner, or is it top right-hand corner? We'll just double check that. It's the top right-hand corner, so it's going to be, if we're assuming it's 100 pixels, so it's going to be 100 and 0. We might make it 80 and 0, so it appears, oops, in the 80 and 10, so it's sort of in the top corner. So, oops, that should be text, not test. So there we go, that's all we need to do for our mouse pos function. So we're using the built-in variables mouse X and mouse Y to display the position of the mouse by concatenating them together to form a string. So we're adding them to a string, and then we're putting them at position 80, 10. So the final one is called a rollover button. So it takes a string and a width and a height, and it draws a single rectangle, and it changes color and when we roll over it. So this one could be quite involved. So let's go through it really quickly though. So we'll create one called rollover. So it takes an X and Y coordinate, int X, int Y. So we'll draw a rectangle. It should also take some text and also a width and a height. So string int W, int height. So first of all, let's just draw our rectangle. And we need to put it at X, Y, and we need to put it at W and height. Next we need to drop our text in, so our text will appear somewhere near. So, oops, it should be string S, so S will appear somewhere, and we'll put that pretty close to X and Y. We can sort that out later on, the fine details. So we've drawn our text. Now the next tricky bit is we want to work out when the mouse rolls over the rectangle. So we want to create a rollover button. So what we actually need to do is use the mouse. So we need to use mouse X and mouse Y. And what we'll be doing is if mouse X is greater than X and mouse Y is less than X plus W, so the X position plus the W, and oops, we haven't quite got something matched up here. Mouse Y is has to be greater than Y, and it has to be less. It should be mouse X rather. It should be less than Y plus height. And if that's the case, we need to actually change the background color. So we can just change our fill to be grey in that situation. Else our fill will need to be white. So what we're doing here is we're detecting what position the mouse is in. So it's within the bounds of our button. We then check and see and draw the and specify that the fill color of the rectangle. That's all we need to do. So you can tweak around with the positions to fuss around to get them to be exactly right, but that gives you the basic structure of what needs to be implemented for Part D. Now, the final part of this exercise is covered off in lectures where we reviewed our Space Invaders game, and there's a sample implementation linked from the first content tile, so I won't run through that today. So that was a bit of a long video, but it contains all of the solutions that are necessary for Part 4 Tutorial 2. So thanks for listening, guys.